we want to talk about today is a little different than what we were just talking about structural isomers. This guy would be, here, let me show you a structural isomer. This guy is what? Pentane. In order to get a structural isomer, you got to have a whole different compound. So I got to take one of these guys off, and take one of these guys off, and move him over here. And this is a whole different compound. He has different properties. He's not the same thing. He is now what? 2-methylbutane. Got it? All right. Here's a different kind of isomer. Something called conformational isomers. Check this out. Okay? Here's one of them. What would I call this guy? What is he called? Everybody agree this is that thing? Okay, now let me show you my other guy. Hold on. All right, here's the other one. It's not. There's something different about this guy. Yeah, I just twisted the hydrogens a little bit. I don't really have two in my drawer. I was full. Yeah, it is the same compound. Now, remember, iso means same. Isomers are same but different. This guy is exactly the same name, even. Exactly the same structural formula. What's different about this guy is his rotation of this carbon around. And they can rotate. You probably didn't know that. But all these carbons can rotate. And so they could have two extremes. There's one of the extremes, where they're all lined up. See it? That's called eclipsed. And I'm going to draw that, show you how to draw that. Here's the other extreme, where they're as far apart as they can get. Okay? They're as far apart as they can get, and that's called staggered. All right, we're going to talk about both of those in conformational isomers. They are molecules that differ from one another only by their rotation about carbon-carbon single bonds. These guys are the same molecular formula and the same structural formula. They simply differ by how you rotate them. And as I said, just due to the simple energy in the room causes these molecules to have enough energy to be spinning around all the time, in and out of these different conformations. But there is a different name for each conformation, and there are different, there's different properties to each one, and that one's more stable than the other. Okay, and they do affect things, depending on which one they're going to be in more often. It's going to affect things about how they will react with other things, and where things, if they were going to be added, might go on to this chain. All right, so it is important that we know about conformational isomers. It's going to affect other things. Let's talk about simple straight chain ones, or what we call aliphatic carbons. Aliphatic means straight chain, same thing. I will also talk tomorrow about cyclocompounds. They have conformational isomers as well. I told you I'd talk more about cyclocompounds in the future. All right, I will tomorrow. But today we're going to stick with just the easy ones, if you call these easy. They're not going to be. It's going to take some three-dimensional thinking. That's the part I actually gave Emily a compliment for, and I think she will actually do okay with this. Some people, I noticed when she was doing those things back there, and some of you other ones who are doing it and having a harder time with it, some people have a real hard time seeing things in 3 dimensions, okay? And those kind of people, there's not much I can do for you. I mean, I will show you as many tricks as I can. But you have to be able to see things in 3 dimensions as we do this, and when we get to stereoisomers, it's going to be even worse. So when you were looking at that screen, and some people were able to say, oh yeah, if I look at it from your side, I will look at this. That's great. That means that you can see that. I noticed some people could, and some people had a harder time with it. All right? That's how you have to draw these. If I simply draw this or this, if I draw it like this on the board, can I tell what conformation it's in? No, I have no idea. There's no way to tell what conformation that's in. I have to find a way to draw this guy so that I can see in 3 dimensions. And the way I'm going to do that is I'm going to draw it this way, like this, where you're actually looking down the bond, not across the bond, but down it. So that if I look down the bond, can't I see that? See that? Right? As if I look down the bond, I can see that one's eclipsed. This one here is eclipsed. The other one was staggered. All right? Let's do that. Let's show you how. We'll take ethane as my first example. And I'm going to draw hello, Newman projections. What's that from? Hello, Newman. Hello.
See, Seinfeld.
Seinfeld, very good.
I love Seinfeld.
Excellent. You know, not many people get those references anymore.
Oh my
Nobody
god,
watches
my brother
Seinfeld
and dad are like obsessed. They know every quote from that.
Oh, well, you could show him how to do humor. That's where it got his name from. Not really. Okay. C2H6. Again, don't do this. I can't just draw him like that. That's not going to help me. So here's what you're going to do. I want you to draw the front carbon as a dot and the back carbon as a circle. It doesn't actually matter which one's a dot or which one's a circle. And then we'll have these guys coming out from them. Now I'm going to have to draw two projections. So watch what I do over here. In the space you have over there, you want to make that, and then move this over here, and you want to make that. It's like a smiley face. You don't draw the smiley part. You don't need this one. Okay? All right, now. I need you to watch. Pay attention how this is going to be done. Look at the front one. We'll call him the dot. It doesn't really matter. All right, we'll call him the dot. And I'll draw the staggered first because it's a little bit easier to see. All right, so I'm going to draw the staggered one. I can hold it also like that so you can see it better like that. That's staggered, right like that. Can you see that? All right, staggered. Front one's got a hydrogen, and another hydrogen up there. So I'll draw a hydrogen. Oh, that was stupid. I draw a hydrogen, and another hydrogen up there. That's the front one, right here. 3 hydrogens, right there. The back one has 3 hydrogens around them as well, but they are staggered at the spaces where the other guys weren't. So he would look like that. Make sense?
Yeah.
Okay. Now, what you can't see are these 2 carbons. This is a carbon here, and that's a carbon back there. And you have to keep that in mind when we go to draw bigger ones. All right, let's try to draw the eclipse for this guy. The eclipse, I kind of have to make a little bit of a cheat. Because if I just look straight down at all I would see would be this, right? That's it. I would